Oh yeah, now let's go. All right, so good morning, class. Good morning, sir. All right, so we have on the board a question that says a chord 20 centimeter long is 12 centimeter from the center of the circle. So we've been asked to calculate correct to 1 dp, the perimeter of the minor segment. So we want to start off by drawing our circle. Don't mind how beautiful my circle is. Just take it as a circle. So this is the center of the circle. So we want to locate this first statement. It said a chord 20 centimeter long. So the next question is, what is a chord? If you remember, a chord is any line that runs from one part of the circumference to another part without passing through the center of the what? Circle. All right, so let's say this is the chord's length. Let's say, let's say this is the length of the chord. We've been told that it is what? 20 centimeter. Now we are told again that a chord 20 centimeter long is 12 centimeter from the where? Center. That means from this center, it is what? 12 centimeter. So we can decide to complete it. This is going to be the radius. This is also going to be the radius. Now, what they want us to calculate here is the perimeter of the what? Very good. Now, you know the formula to calculate. Let's write it here. Perimeter of a segment is given as the length of an arc plus the what? Length of a chord. Okay, so from here, now we've been told the length of the chord from this question. If you look at this length of a chord has been given as what? 20 centimeter. So what we have to deal with is this length of what? An arc. And the length of an arc is given to be theta over 360 times 2 pi r. Now, if we are going to solve this question, we need theta. We need radius. We know that pi is what? 22 over 7. That means we need to find a way to get this theta and r. So let's go back to this shape that we have here. So let's bring out a part. So we want to assume that this whole place is given as theta. But we want to bring out a part of the triangle first. So let's take this place. Let's label it angle A. The entirety from here to here is theta. But we want to say this small part is angle A. And this other part is also angle A. Then later on, we'll add them together and it will give us our theta. So here to here is 12 centimeter. That means this place is also going to be 12 centimeter. Now this part, the full length of the chord is 20 centimeter. If you divide it into 2 equal parts, you have what? 10 centimeter. So straight up, we can get our radius from here using Pythagoras theorem. So we know that Pythagoras theorem is hypotenuse squared is equals to opposite square plus what? Adjacent square. And from this diagram, our radius is representing the hypotenuse. So we can say r squared is equals to 12 squared plus what? 10 squared. So r squared equals to 144 plus 100. And our r squared is equals to what? 244. And our r is, we take the square root of both sides, and we have 244. And our r is going to give us, let's find the square root of 244. Okay, this is going to give us 15.6 centimeter to 1 dp. So we've successfully gotten the radius. The next thing we want to try to find is the theta. But don't forget, I said this place is A. So we want to get A first. Now from this diagram, the side facing angle A, which is 10 centimeter, is representing the what? Opposite. Now this 12 centimeter as well that is given, is representing the what? Adjacent. Don't forget this side R is representing the what? The hypotenuse. Now, under SOHCAHTOA, which one is given to have opposites and adjacent? So if you remember SOHCAHTOA. So we see that TOA captures opposite over what? Adjacent. So we can easily say tan theta is equals to opposite over adjacent. So tan, our given angle here, we've used A. So let's say this is A equals to our opposite is 10 over 12. So that means that tan A is equals to 10 divided by 12. That's going to give us 0.8333. So let's leave it to 4 decimal places. Now from here, A is now going to become, now from this point now, when tan comes to the other side, it becomes tan inverse of 0.8333. So from here, we can get that our A. So what's the tan inverse? 0.8333. And that's going to give us 39.8. Now, since A is 39.8, all right, so this is going to give us A is equals to 39.8 degree. All right, so this is going to give us A equals 39.8 degree. But don't forget, the given angle we are looking for is this angle A plus this angle A. So since we have gotten one of the angles, it means theta is 39.8 degree plus 39.8 degrees. So theta is equals to 39.8 times 2. That's going to give us 79.6 degree. So now that we have successfully gotten our theta, we can go right into the question that the perimeter of the minor segment is length of the arc, which is this formula. So right away, let's just substitute. Our theta is 79.6 over 360 times 2 times 22 times our radius 15.6 plus, now don't forget the formula for perimeter of a segment is length of an arc plus what? Length of a chord. Now in the question, the length of the chord is what? 20. So from here now, we can say that the perimeter of the segment is, so let's just multiply all the numerators here and we'll divide it by the denominators. So that's 79.6 times 2 times 22 times 15.6. We press our equals to divided by 360 divided by 7. That's going to give us 21.68. Or let's just leave it to 1 dp. That will give us 21.7 plus 20. So the perimeter of the segment is going to be 21 plus this will give us 41.7 centimeter to 1 dp. So this is the answer. You won't clap for your teacher. Ah.